Number 42 is another matching problem, and we could check our asymptotes to help us match. And so we know that we have a vertical asymptote at x equals -2, since that makes the bottom go to 0. So that looks like it eliminates choice 3 for us. The other ones all have a vertical asymptote at -2, it looks like. We also know that since the degree on top is greater than the degree on the bottom, we're going to have a slant asymptote. That eliminates choice 1. We just need to figure out what that slant asymptote is. So to do that, I'm going to do some long division. And I know that I need an x to get an x squared. And I'm going to change the signs. So I have a -2x plus 0, and that would be an x minus 2 as my slant asymptote. So if I look at the two graphs, it looks like that choice 4 gives me an asymptote at x minus 2 because it has a y-intercept at -2. In number 43, we want to match the equation with the graph, and we notice that in this graph we have a hole at 1. So that means that if I factored it, a x minus 1 would need to cancel out. So that would eliminate choice A because we can't factor, nothing would cancel there, and choice B. So if I factor the remaining 2, I get x minus 1 over x minus 1 x plus 3. And if I factor choice D, I get x minus 1 x plus 3 on the top and an x minus 1 on the bottom. So both of these would give me an x minus 1 that would cancel. However, I would want the x plus 3 on the top because that is the line that I'm left with. So it must be choice D. In choice C, we're left with 1 over x plus 3, which would give us a vertical asymptote at -3, which we don't have in this graph. In problem 44, we want to find the slant asymptote. So I'm going to need to do polynomial long division. So I'm going to put x squared plus 0x plus 1 on the outside, and x cubed plus 7x squared plus 0x minus 1 on the inside. So in order to get an x cubed, I'm going to need to multiply by an x. And then I want to change all the signs. So I end up with 7x squared minus x minus 1. And then I'm going to need to have a plus 7. And that is my slant asymptote, y equals x plus 7. So that'll be choice B. In number 1, we know that we cannot plug a 1 in or else we'll get 0 on the bottom. So our domain is -infinity to 1, 1 to infinity. And since we can't plug in a 1, we know that our vertical asymptote will be x equals 1. Since the degree on the top is the same as the degree on the bottom, our horizontal asymptote will be 1 divided by -1, since we have a negative x. So we'll have y equals -1. And we don't have a slant asymptote since we have a horizontal. In number 2, we cannot plug in a -12. So our domain will be -infinity to -12 and -12 to infinity. Our vertical asymptote will be x equals -12, since that's what we cannot plug into the bottom. Since the degrees are the same again, our horizontal asymptote will be 5 divided by 1, which is just y equals 5. And we will not have a slant asymptote. For number 3, I'm going to first factor the bottom to x minus 6, x plus 3. So I know that I cannot plug in a 6 or a -3. So my domain will be -infinity to -3, -3 to 6, and then 6 to infinity. My vertical asymptotes will be 6 and -3 since I can't plug those in. Since the degree on top is smaller than the degree on the bottom, I will have a horizontal asymptote at y equals 0. And since I have a horizontal asymptote, I do not have a slant asymptote. For number 4, I cannot plug in a 3 or a -3 since it's an absolute value. Oh, never mind. I can plug both of those in because it's a plus. So I'll always have a positive number on the bottom. So my domain will be negative infinity to infinity since I can plug anything I want into the bottom. Since my domain is negative infinity to infinity, I will have no vertical asymptotes. However, since this is an absolute value function, I will have 2 horizontal asymptotes. Since the degrees are the same, my first horizontal asymptote will be at 1, and my second will be at -1. And since I have 2 horizontal asymptotes, I do not have any slant asymptotes.
Harlan, are you a star?
For number 5, we cannot plug in a 3 into the denominator, so we will have a domain of negative infinity to 3 and 3 to infinity. And I will have a vertical asymptote at 3. In this case, I won't have any horizontal asymptotes since the degree on top is bigger than the degree on the bottom. Instead, I will have a slant asymptote, and I will need to do some long division to figure out what that slant asymptote will be. So I will multiply by x and then change the signs. So I have 2x plus 1, and I would need a 2. So my slant asymptote is y equals x plus 2. In number 6, there are 2 numbers I would not be allowed to plug in. I would not be allowed to plug in 2 or -2. So my domain would be negative. Oh, but I should factor this first in case something cancels, because I see that there's an x plus 2 on the top. So I have 5x times x plus 2 over x minus 2 times x plus 2. And the x plus 2's cancel, so I'm left with 5x over x minus 2. So that will give me a whole instead of a vertical asymptote. But still, we cannot take -2 and plug them in. So my domain is negative infinity to -2, -2 to 2, and 2 to infinity. I'll still have a vertical asymptote at 2 because that did not cancel, but I'll have a whole at x equals -2 since the x plus 2's canceled. Horizontal asymptotes, if I look at my new equation, the degrees are the same, so I'll have a horizontal asymptote at y equals 5, and I will not have a slant asymptote.